In the next few examples, I would like you to learn how to find or evaluate inverse trig functions in context. First, this example number 2 says use the calculator if necessary to figure out these values and express your answer in both degrees and radians, round to 4 decimal places. Okay, so in this example, I just basically want you to become familiar with your calculator and entering this in your calculator. Every calculator is different, so make sure you do know how to enter this in your calculator for testing and homework. So here you see that in this calculator, the inverse functions are right above the corresponding regular trig functions. Sine inverse, cosine inverse, tangent inverse are right above. So let's do then find out cosine inverse of negative 0.9. So first I want the answer in degrees. My calculator, oops, I keep moving that, sorry. My calculator is already in degrees, so what I'm gonna get is degrees. So I'm gonna put negative point or negative 0.9. You see, if I hit it with cosine inverse, that's backwards. So I really have to do it this way. Cosine inverse of negative 0.9. Okay, and that's it. So let's see what we get. We get 154 degrees. So the answer to this is 154 degrees. And I'm going to round to 4 decimal places as per the instructions. 154 degrees, 1581. Okay, and that's it. So now let's get the answer in radians. So I have to change here from degrees to radians. And now let's do it again. So it's going to be cosine inverse of negative 0.9. And this is the answer in radians. So we get 2.6906. This is radians. Okay, and that's basically how you do that. So this is simple. Let's do tangent inverse of 0.25. All right, so let's go back. Let me just leave it like that. Radians. So I'm gonna figure out what is tangent inverse of 0.25. We get, so that is 0.244. Oops, that's gonna become 50. When you round to 4 decimals, that actually becomes 50. Sorry, 50. Yeah, that becomes the 50. Okay, so that would be in radians. Now let's clear it and change it to degrees. Let's do it one more time. Tangent inverse of 0.25. We get 140. I mean, sorry, 14.036. And this is degrees. So you can write the little circle. Okay, let's do 2 more. This one says sine inverse. So sine inverse of negative 0.75. And I'm going to get the answer in degrees because my calculator is in degrees right now. And I get negative 48.5904, rounding to 4 decimal places. And don't forget to write a little circle, otherwise the computer would understand that that's radians. Right? You will get it wrong if you forget the little circle. Okay, now let's do it again in terms of degrees, radians. So that's going to be sine inverse of negative 0.75. Oops, I forgot to change it. So let's change it now. Okay, now it's in radians. And the answer is negative 0.8481. This is radians. And lastly, the last one says cosine inverse of 2. For this one, you don't need a calculator because if you remember, that's not in the domain. The domain of cosine inverse, the numbers that I'm allowed to plug in are between -1 and 1. That was the case for all of these. Negative 0.9 is between -1 and 1. That's in the domain of cosine inverse. C, negative 0.75 is between -1 and 1. That's in the domain of sine inverse. The domain of tangent inverse is everything, so no matter what, that's going to make sense. But for this one, 2 is out of bounds. All right, so this is going to be, does not exist. So I don't even need a calculator for that. But if you do try to enter it, cosine inverse, you should get an error. The domain error is not in the domain. Okay, now let's do these in context. In the context of either a geometry problem or a story problem. So this one says, solve the triangle for the angle theta. So given this triangle, let's figure out what theta is. First, we think of using SOHCAHTOA, which of the three basic trig functions, sine, cosine, tangent, relates all these three things. That would be cosine. So that would be adjacent over hypotenuse. So we get that cosine of theta is 9 over 12. Now, to get theta from there, that's what we want, theta, we rewrite this equation using cosine inverse. If you rewrite this equation using cosine inverse, remember that swaps the inputs and outputs. So now the output, 9 over 12, becomes the input, and the input becomes the output. So actually then, the output of this thing is theta, which is what I really want. So let's put this in the calculator. For geometry problems, remember that we usually give the answer in terms of degrees. So let's change this back to degrees. And say, okay, we want cosine inverse of 9 divided by 12. And that is 41. So that means theta equals 41.41. I'm using 2 decimals. They'll always specify in the homework or the test. They will always tell you how many decimals. Right? So 41.41 using rounding to 2 decimals. Okay, if you understood that, give this one a shot and find theta in that triangle. Pause the video and give it a shot. Okay, assuming that you're back, let's do it now. This is going to be, okay, what is the trig function that I need here that relates these three things? It's not cosine, so it would be sine. Sine of theta equals opposite over hypotenuse. And now, to get theta, I apply sine inverse. So I'm gonna get sine inverse of 6 over 10. Okay, sine inverse of 6 over 10 equals theta. Now let's put this in the calculator. Sine inverse of 6 over 10. And we get 36. Theta equals 36 degrees, 0.87. Okay, that's it. So in the homework, normally you will find story problems where once you draw a picture for the problem and strip the problem of all the context, what you're really left with is just a triangle for which you have to figure out an angle, a right triangle. So here's just one example of what you could encounter. So it says Ethan is watching a fireworks display from an observation spot, which is 7.5 miles away. Question, find the angle of elevation from Ethan to the fireworks. So Ethan is, so let's draw a picture real quick. That's the ground. Ethan is here. Okay, and the fireworks are up here in the sky. And then the angle of, so I'm assuming that I'm really far away, so everything looks very tiny. And Ethan is looking up at at the fireworks. The fireworks are at a height of 0.4 miles. The height of that is 0.4 miles. And he is 7.5 miles away from where they threw those fireworks. Question is, what is the angle of elevation? That's the angle of elevation. Okay, so now think, what is the trig function that relates all these three things? This side, and that angle. Okay, the answer is tangent. Tangent relates all three things. Tangent of theta equals opposite over hypotenuse. So 0.4 over, oh, sorry, opposite over adjacent, my bad. Okay, opposite over adjacent. Okay, there we go. And now get theta by using tangent inverse. So tangent inverse of the output becomes the input, and the input becomes the output. So this is theta. So now let's put it in the calculator and get the answer. So we want tangent inverse of 0.4 divided by 7.5. And you get 3 degrees. Let's use 4 decimals. Okay, that's it.